Hey there. So I've been thinking about yesterday's Ruby countdown timer that I threw together, and this is the code that we ended up with from that one. If you haven't seen the screencast, I recommend going back and watching that one first before watching this one. But I've been thinking about the solution, and it wasn't intended to be particularly pretty, but as I was thinking about it, there were another couple possible implementations that came to mind, and a couple things that I pointedly didn't like about this solution. So I'm going to at some point go over kind of an alternate implementation that takes kind of a different approach. But for this one, I'm going to look at one redundancy that's bothering me in particular, and then also just as kind of a exercise in looking at Ruby syntax, I'm going to take these lines, everything except for the kind of argument handling at the beginning, and reduce them down to a single line. This isn't necessarily something I recommend doing, but in kind of moving things around, I sort of played with the possibility and got it to work, and I thought it would be kind of an interesting exercise to go through. So that's what we're going to do today. So first off, the thing that's bothering me is this conditional at the end here, this if time is greater than 0. And the reason it's bothering me is because up in this line we're already doing a check, and it's kind of redundant, and it's necessary to suppress that weird 59 output we were getting last time. But I think that's kind of a earmark of sort of a poor design here, that the loop keeps running after the timer is up, basically, which is to say when the time is less than 0. It's not necessarily, I mean, for our purposes it does the job of the countdown timer, but it's also not particularly great in my opinion. So the first step here would be kind of to take these and consolidate them. We could put this T in the while, except that we don't have it defined yet because we're defining that down here for each loop through. And really, if we're kind of doing this if check at the top, what we can actually do is get rid of this altogether and make this a loop instead. Loop do being, loop is a keyword, and you pass it a block and it infinitely runs that until you break out of it. So let's do that here, and instead of defining T down below, let's define it first thing, and we're going to break if time is less than 0. So this will take care of all of the checking that we need to do. And actually, let's test this, and sure enough, it works as before. So this is kind of more, this kind of better illustrates the purpose of what we're doing here, but and that actually I think works better in a way than the while loop. I think this might read a little clearer. It's at least more concise in that it only has one conditional, and I like that about it. So that said, from here on out, we're going to do absolutely nothing that I necessarily recommend doing. I just want to show that it's possible to do. So from here on out, tread with caution. So first thing, we're actually going to want a while loop up here yet, and there may be a way to do what I want to do with the loop, but I'm actually not particularly sure how to do it. Maybe we'll take a look at that at the end, but for the time being, I want the while loop. So what I'm going to do is I'm going to kind of try to cram this logic that we had before all into the loop itself. So what we're going to do is take the variable definition up here and put it in the variable assignment up in the while definition. And I think for certain control structures like while and if, this might throw a warning, but it's syntactically fine because it performs the variable assignment and then returns that value to the while. So this will evaluate to the time value that we were using, the numeric, and then that is truthy, so the while will pass. But we also need the check up here, and to do that we can wrap this in parentheses and then do the check up here. So this looks like a complete mess. So let's take a look in Pride and see precisely what's going on here. So first we have the variable assignment and it's returning a numeric, so let's just pretend this is t equals 1. Now if we did this, this is going to return true because it's doing the because of the order of operations, it's doing this, which is not what we want. So if we do this instead, it performs the assignment and then does the comparison, returns true, and then we have t equal to what we want it to demonstrate this. Let's change it, and t is equal to 2. And then furthermore, we can use this in a control structure to do what we want. So that's what's going on in this bit. And if we rerun this, we've got our countdown timer still. So moving back into the file, we've kind of gotten our time check tightened up, and we can also tighten up this line. First, we can get rid of the min and sec variable, which makes this line pretty much completely unreadable because it's really almost impossible to tell what this does here. So this is certainly the better way to have it, but this is one line and that's what we're shooting for. Additionally, to make things even worse, we can cram this in, and this will do the exact same thing. Because of the, I believe because of the order of operations here, this product, this multiple, will get executed first, and then the string concatenation will happen, and then the printf will do its job. Furthermore, we can throw an and in here, and that will work exactly as we want it to. And the and keyword works here because normally if we wanted this to work the way it's working, we would have to do something like this if we were using the ampersand operator. Because of order of operations, it would try to and the 1 with the result of this, the result of printf. We would try to and it with 1 and then pass that to sleep, which is not what we want. And here works so that it lets whatever's in front of it evaluate, and if it's truthy, the expression that follows is run. So that's why this works. So next up, to tighten this up, just like we can throw an if at the end of a line, we can actually throw a while at the end of the line as well. And this works, but it blows up because our t variable is undefined. Apparently when we have a situation like this, the fact that the t occurs in the line before the while is run in its initial execution, it's undefined. So we can solve this by assigning t to e as a default value, which is fine if e value is basically greater than 0, which it's always going to be if we're using it as a timer. And this works to kick things off. So we can throw this on the front here, except that now we'll want to conditionally assign this because it will be in the first run, which is like what we were doing up here. It will be yet undefined, but on the second run through, after the while has been executed, it will need to be set as the t value that we're calculating, and so we won't want to set it to e. And so this conditional assignment will not do that if it already has a value there. So then this should work as well. Sure enough. And lastly, we're going to want to bring up the espeak command here, and we can execute this with an OR, which works kind of in the opposite way of the AND operator, where if whatever is evaluated before it returns a falsy value, it will execute what follows. So that is the case when the while loop is done, then the espeak command will be executed. So we can test this by using a shorter timer.
Ding.
And sure enough, it works. And just to go into detail on this OR operator real quick, let's take a look at pry, what we're doing. So the entirety of what comes before this is, I think, syntactically, is a while loop. It's the return of the while loop, or espeak ding. So in that case, we can see what that looks like by doing while false to see what a while loop that's getting broken out of looks like, and that returns nil. So we can see what we're getting by saying nil or puts here, and that will output here. So this is the case where we're throwing our espeak command. So that does it for our incredibly contrived Ruby countdown one-liner. Once again, I do not advocate doing anything like this. This is clearly entirely unreadable. If you were to come back a month from now and look at this and try to make sense of it and change something, you would probably have an incredibly hard time, even if you wrote it yourself. But having said that, I think it's an interesting exercise and an interesting look at what is syntactically possible in Ruby, even if it's a terrible, terrible idea. Well, I hope you found today's episode interesting. If you have any questions or episode requests, you can tweet at me at ForkBabam. And if you'd like to download episodes or support the show, please feel free to visit the Gumroad link in the show notes below. Thanks for watching, and I'll see you again soon. Interesting look at what is syntactically possible in Ruby, even if it's a terrible, terrible idea. Yasha.